Hey guys, now that we've learned a few new tricks, i.e. the factor theorem and the remainder theorem, we are now ready to factorise and solve harder cubic equations where x is not a factor of every term. So basically we have an x cubed term, an x squared term, an x term, and a constant term at the end. So let's get cracking. Okay, so for example 1, we want to write as the product of three linear factors, f of x equals x cubed add 6x squared add 11x add 6. And then for part b, we want to solve f of x is equal to 0. So, given here that we are told there are three linear factors, we don't need to do anything too tricky. We can just use the factor theorem to track down our three factors. Later on we're going to see questions that just ask us to factorise a cubic and then maybe solve it, but it doesn't say anything about how many factors we're looking for. So we're first of all going to find the linear factor and the quadratic factor, then we can use the discriminant on the quadratic factor to see if we can factorise that or not. So it's going to get quite complicated. Okay, for this one then, part A. So, x cubed add 6x squared add 11x add 6. Well, we're going to use the factor theorem, and what we're going to do is start off with the simplest number that we could substitute in. Now that would be 1. So, we're going to evaluate f of 1. So, if f of 1 is equal to 0, remember that tells us f of x minus 1 is a factor. If not, then it's not a factor. So, f of 1 is going to give us 1 cubed is 1. 6 times 1 squared is 6. 11 times 1 is 11. And then plus 6 on the end. Now, without even adding that up, we can tell quite easily that that is not equal to 0. Therefore, x minus 1 is not a factor. Okay, so then the next one that we want to try is f of minus 1. So always start small and just work up. So f of minus 1, well, minus 1 cubed is minus 1. Minus 1 squared is 1. 6 times 11 is 6. And then we've got 11 times minus 1, which is minus 11. And then we got plus 6 on the end. Now 6 plus 6 is 12. Minus 1 minus 11 is minus 12. So this does equal 0. So that tells us x plus 1 is a factor. So what we can do at this point is we can now write f of x as x plus 1 times x plus b times x plus c. Okay, now the good news here is as well, we're not going to actually have to use the factor theorem to find all three factors. If we just find the second one here, then we can easily work out a third. So the next thing we would want to try is f of 2. So f of 2 would give us 2 cubed, which is 8. Add 6 times 2 squared, 6 times 4, 24. Add 11 times 2, 22. And then add 6. Now again, everything there is positive, so we can easily see that is not equal to 0. Therefore, x minus 2 is not a factor. So, the next thing to try then would be f of minus 2. Now, f of minus 2 is going to give us minus 2 cubed, which is minus 8. Minus 2 squared is positive 4, so 6 times 4 is 24. 11 times minus 2 is minus 22. And then we got plus 6 on the end. Now, 24 plus 6 is 30. Minus 8 minus 22 is minus 30. So this does indeed equal 0. Therefore, x plus 2 is a factor. So, up to here we can now write f of x as x plus 1 times x plus 2 times x plus c. But now instead of faffing around with the factor theorem, we can actually find the value of c quite easily. So, remember from the original function, the constant term at the end is 6. Now that constant comes from multiplying the constants in the bracket. So, we know then 1 times 2 times c has to equal 6. So 2c is equal to 6. So c is equal to 3. So our third factor is x plus 3. So f of x is x plus 1 times x plus 2 times x plus 3. So that's part A done. Part B wanted us to solve f of x is equal to 0. So if we set that equal to 0, just like with quadratics now, we get our solutions by solving each separate bracket equal to 0. So x is minus 1, minus 2, and minus 3. Jobs again. Okay, example 2, so we want to do the same job, right, as the product of three linear factors. F of x is x cubed plus 5x squared minus x minus 5. And then for part B we want to solve f of x equal to 0. So, again, we know we're looking for three linear factors. We can just use the factor theorem. So again, start off with the most simple thing to substitute in. So f of 1. Now, f of 1 is going to be, well, 1 cubed is 1. 5x squared, 5 times 1 squared is 5. Minus x, so minus 1, and then minus 5. 1 plus 5 is 6, minus 5 is 1, minus 1 is 0. So, that's good. we've hit gold straight away. So if f of 1 is 0, this implies x minus 1 is a factor. Good times. Okay, so the next thing I would try is f of minus 1. Just because 1 has worked does not mean minus 1 won't work. So let's check it. F of minus 1 is going to be, well, minus 1 cubed is minus 1. Minus 1 squared is positive 1. 5 times that then is positive 5. Minus 1 is plus 1. And then we got the minus 5 at the end. So we've got a minus 1 and a positive 1, a positive 5 and a minus 5. So this 2 is equal to 0. So this tells us x plus 1 is a factor. So we don't need to use the factor theorem anymore, because we now know 2 factors. We can work out the third one. So we can now write f of x as x minus 1 times x plus 1 times x plus c. Now, if we look back at the original function, we know the constant term at the end was minus 5. So that tells us these 3 constants multiplied together have to give us minus 5. So, in other words, minus 1 times positive 1 times c has to equal negative 5. So minus 1 times 1 times c is minus c. Minus c is minus 5. And therefore c is 5. So we can write f of x as x minus 1, x plus 1, x plus 5. Like that. If you want to check, of course, use the factor theorem, substitute in x equals minus 5. So, then for part B, we want to solve f of x is equal to 0. So, our solutions are x equals positive 1, negative 1, and negative 5. Jobs again for number 2. Okay, number 3, so we want to write as the product of 3 linear factors. F of x is x cubed minus 3x squared minus 33x plus 25 plus 35. And then for part B again we want to solve f of x is equal to 0. So, start as we've started with the 2 previous ones. Let's try f of 1. So, f of 1 is going to give us, well, 1 cubed is 1. Minus 3 times 1 squared is minus 3. Minus 33 times 1 is minus 33. And then plus 35. Well, 1 minus 3 is minus 2. Minus 33 gives us minus 35. And then plus 35 gives us 0. So this is actually telling us very nicely from the get-go. X minus 1 is a factor. Good times. Okay, next up we might as well try f of minus 1, because it's good practice. So, f of minus 1, well, it's going to be minus 1 cubed, which is minus 1. Minus 3 lots of minus 1 squared. Minus 1 squared is positive 1. Minus 3 times that is minus 3. And then we've got minus 33 times minus 1. That's going to give us positive 33. And then we've got plus 35 at the end. So, we can easily see that's not equal to 0. So, x plus 1 is not a factor. Now, do we need to try f of 2 or minus 2, or f of 3 or f of minus 3? No, we don't. This is where we can now get a little bit clever. So remember, the three numbers in the brackets multiply together to give us this number at the end. So here our three numbers are multiplying together to give us 35. Now when it comes to 35, you've either got 1 and 35. We don't want to try 35 though yet, unless we really have to. Or we've got 5 and 7. So we don't need to try 2 minus 2, 3 minus 3, 4 or minus 4. We can go straight to f of 5, because that is the next factor of 35. So, if we do just that then, f of 5 is going to give us 5 cubed is 125. Then we've got minus 3 lots of x squared. 5 squared is 25. 3 times that is 75. So we got minus 75. Then we've got minus 33 times 5. Lovely. 33 times 5 is going to be 165. So we got minus 165. And then plus 35 on the end. So what's that going to give us? Well, 125 minus 75 is 50. Minus 165 is minus 115. And then add 35. Well, it's definitely not equal to 0. So, x minus 5 is not a factor. So, then we're going to need to try f of minus 5. So, minus 5 cubed is minus 125. Minus 5 squared is positive 25. So, minus 3 times that again gives us minus 75. Minus 33 times minus 5 is going to give us positive 165. And then we got the plus 35 on the end. Now, minus 125 minus 75 is minus 200. 165 at 35 is positive 200. So, this is indeed equal to 0. So, that tells us x plus 5 is a factor. So, up to here, we can now say f of x can be written as x, what was our first factor? So our first factor was x minus 1. So we can now write it as x minus 1 times x plus 5 times x plus c, like that. Now we know the constant in our cubic is positive 35. So minus 1 times 5 times c equals 35. Minus 5c then is 35. If we then divide by minus 5, c equals minus 7. So finally, f of x can be written as x minus 1 times x plus 5 times x minus 7. So we factorised it. Now for part B, we just want the solutions to f of x equals 0. So first bracket tells us x is positive 1. Second tells us x is negative 5. And the third one tells us x is positive 7. I like that. Cool. Okay, so hopefully that's given you a flavour for using the factor theorem to factorise and solve cubics. You probably noticed up to here, we've always had a single positive x cubed term. So I was planning to do this all in one video, but look how long this has taken. Next up, we're looking at trickier ones, where we don't know how many factors we are looking for. So we might have 3 linear factors, we might have 1 under quadratic, or we might have just 2 linear factors where 1 is repeated. So that's when things start to get quite tricky. We'll have a look at that in the next video. Take care, guys.